Section 11.1, looking at circumference and arc length. Our essential question, how can you find the length of a circular arc? First thing we're defining is circumference, which is the distance around the circle. So our formula for that, the formula most people are probably more familiar with is 2 pi r. You can also write that as pi d. And in these two formulas, r is my radius and d is my diameter. Okay, your diameter is twice the radius, so pi d works as well. Part of the reason 2 pi r is more familiar is a lot of times you're given the radius, but also it relates to area of a circle as well. So typically I will use 2 pi r, but pi d is also an acceptable way to think about it. So example 1, find the indicated measure. Okay, round decimals to the nearest hundredth. Okay, so A says the circumference of a circle with radius 11 meters. Find the approximate and the exact answer. So they're actually asking us for two answers here. So 2 pi times 11 is what we get when we plug it into our formula. Right? So the exact answer, you do 2 times 11, that's 22. And then you just leave it in terms of pi, 22 pi. This pi is irrational, it continues forever. So whenever you multiply by pi, you're going to have to round to some degree, which is why 22 pi is our exact answer. It also says find the approximate answer. That's when I am rounding. So when I multiply out 22 pi, right, I'm going to get 69 point something. Now, watch what you're doing here and be consistent in what you're doing. If you use 3.14, you're going to get a lower answer. You're going to get 69.08. If you multiply by pi in your calculator, that includes more of the decimal, and therefore the number is higher, which is 69.12. Okay, so sometimes you'll see instructions that will ask you to do one or the other. So then make sure you're doing that, because it does affect your answer. It's not by a huge amount, but it does affect your answer. B then asks for the radius of a circle with a circumference of 18 yards. So here we're working backwards. 2 pi r is equal to 18. Divide by 2. You have pi r equals 9. And then I'm going to divide by r. Okay. 9 over pi would be your exact answer. And a lot of times you will find that to be acceptable. As you go into higher level math classes, you would leave it in that terms more and more. But if I'm rounding, if I'm doing decimals, which more people are comfortable with, I would get 2.86 yards. Example 2. The dimensions of a skateboard wheel shown to the right here or in millimeters to the nearest millimeter. How far does the travel make it when revolutions? Oh, how far are you traveling when it makes 35 revolutions? Right. So first thing is figuring out your radius. If I look here, I have 20, 15, and 20. None of those are radiuses. 15 is the diameter here. And then I have this whole diameter. So I'm going to add those up. 20 plus 15 plus 20. Which gets me 55. Okay. So then the distance from here to the outside, that's going to be half of that. So my radius is 27.5, which is half of the 55. So then when I do 35 revolutions, I'm going to do my circumference times 35. So 35 times 2 pi r, which is 27.5. Okay. So my circumference is 172.79. Multiply that by the 35. I get 6,047.65 millimeters. Then example 3 asks us to find the perimeter of the region. Okay. But we have these curves in here, right, which we'll have to deal with as circles. Now this will end up being nice because we have 4 of them, so it works out evenly. We're going to sort of see how that works when we flip the paper over, how else we can work with this. So when I'm looking at the region, make sure you're adding everything up. I'm going to look at the flat first. So I have 2 here, plus 6 there, plus 2 here, plus 6 here. And then I have my circle. I have 90 degrees each, so 4 times 90 is 360. So I have one full circle. So I can just treat this as 2 pi r. The thing is that I need to know my radius. So if I look here, this is 6. Over here we say this is 2. So that means I have 4 left. And since these are both 90, it's going to be divided evenly. So this here is a radius of 2. So I have 2 pi times 2. Add up here, I get 16. 2 times 2, I get 4 pi. Okay, this would be my exact answer. Okay, this doesn't specify what it's looking for, but 16 plus 4 pi is an acceptable answer. That is the exact answer. I can't combine it. If I'm looking to buy a fence or something, though, that is not helpful. So if I multiply that out, I get 16 plus 12.57, and I would get 28.57 inches as my perimeter of that thing. Flipping over, we're sort of going a step beyond what we've been doing here. We're looking at the arc length. So this is, we looked in chapter 10 at the degrees of the arc. Here we're looking at the actual length. So the arc length is part of the circumference. Okay. And it's the distance to cover the arc and that's in units, not degrees. Okay. So if I have 2 circles and they're different sizes, 60 degrees is going to be a different length in each thing. So here we have how we solve this. In a circle, the ratio of the length of a given arc to the circumference is equal to the ratio of the measure of the arc to 360. Okay, and that statement there matches with the first formula here. Arc length of AB here over 2 pi r, which is my circumference, equals the measure of AB, that's in degrees, over 360. You can also do this as a formula. You can say arc length is equal to the measure of AB over 360 times 2 pi r. What I'm going to be doing here is I'm going to be using this. The advantage is I'm always keeping things in the same space, and then I'm just cross multiplying. So where my variable is not as much of a problem. In this one, okay, if I'm finding arc length, this is really easy. I plug in, multiply, and solve. Right? And that should be times there. Some of the things got thrown off here. But if I'm looking for the measure of the arc, or if I'm looking for r, now I need to start doing math. And it's not generally hard, but people get confused because they're moving the 360, they're moving the 2 pi, moving things separately. So this I just plug everything in, cross multiply, and solve whatever for whatever my variable is. Example 4 asks for the length of arc AB. Okay, so the arc length is what I'm looking for, so that is my variable. They give me a radius of 2, so I have 2 pi over 2 times 2, right? And then that is equal. The 360 is always in the bottom here, and then they give me degrees of 88. So again, I cross multiply. Now you can simplify things first. You can do 2 pi times 2 first, or you can cross multiply at the start. Here if I cross multiply at 360x equals 1105.87. And then I divide by 360. So then I get x is 3.07. You could also leave this in terms of pi depending on what you're doing, and then reduce it. Right? For what we're doing here, I'm going to keep these as decimals, I think, for the most part. Okay, so then that is the length of that arc, and that should be in meters. B is now asking me for a different thing. B is asking me for the circumference of Z. Right, it says circle Z, so we're looking for the circumference of Z. So here they give me the arc length is 3.44. Then I have 60 over 360. Now I can write 2 pi r here. A lot of times when people do that, they continue to solve for r, which is not what they're asking me for here. It's not a problem if I notice it, because I can plug r back in. But I'm going to replace that with c, and then so then I don't need to worry about it. So cross multiply, I get 60c equals 1238.4. Divide by that c, and I get my circumference is 20.64. And then the last one here, C, asks me for the radius. So here again, they give me, what is that in? 20.64. Watch, go back to the previous problem. 20.64. They give me this as centimeters. So my circumference there is in centimeters. C, we're looking for the radius. So again, they give me my arc length. But here I actually want to find r. So I'm going to write 2 pi r there. My degrees are 150. And that's over the 360. Cross multiply. We get 3,780 equals 942.48 r. Divide by the 948, and I get a radius of 4.01 feet. Completely switching degrees here. Didn't mean that to be a pun. Switching what we're looking at here. We're looking. This is involved in circles, but here we're looking at degrees and radians. So degrees are what you're probably used to measuring angles in. Radians is another way you can do that. You see this more when you get into trig and pre-calc. This is just a brief introduction here. So we have 2 formulas for converting degrees to radians or radians to degrees. Okay? So a full circle in radians is 2 pi. So you have 2 pi over 360. You can also use pi over 180. And then going the other way, you would flip your 2 fractions. Right? I'm going to use the 180 over pi when I show it. Right? Example 5 asks us to convert the degrees measures to radians. So I have 105 degrees. To convert degrees to radians, right, I want to do pi over 180. So I have 105 times pi over 180. So what I'm going to do there is I do 105 times pi, divide that by 180, and that gets me 1.83 radians. Negative 60, same concept. I would do negative 60 times pi, divide that by 180. I get negative 1.05 radians. 270. We're doing 270 times pi over 180. So 270 pi divided by 180 gets me 4.71 radians. You could leave these in terms of pi as well. If you have 270 over 180, you have 90 that goes into both of those. Right? So this would be 2 and this would be 3. So you would have 3 pi over 2. And that would be the way you would see it more in trig and pre-calc. But for what we're doing here, I'm going to keep it in decimals because we're more familiar with that. But that's why when we come down to here, you see these written as they would be written in a trig class or a pre-calc class. So now I'm doing radians to degrees. I'm flipping my fraction. Okay? And one of the nice things here is the pi now goes on the bottom, so it's just going to cancel out. When I have 3 pi over 4 times 180 over pi, the pi's cancel. So 3 times 180 divided by 4, that gets me 135. See the same thing on the next one. 8 pi over 3 times 180 over pi. The pi's cancel. 8 times 180 divided by 3, I get 480. Pi, remember here we have pi over 180. 2 pi is a full circle. That's just going to be 180. Right? We know what that is. But if you want to look at the math, we have pi times 180 over pi. Right? So the pi's cancel, and I just have 180. And that's how we convert between degrees and radians. If you look in your calculator, you probably have a thing where you can change this, and you can change from degrees to radians. That's probably not going to be super helpful here, but again, that's why you have radians on your calculator.